All right, welcome back, everyone. This is section 7, date and time functions. One of my favorite sections, hands down one of the most important sections in this entire training course, simply due to the fact that many people run into a number of issues and headaches trying to work with dates and times in Excel. I know I spent about a year kind of fumbling through these, not quite understanding what was going on, until I really sat down to understand how Excel is thinking about dates and how Excel is processing dates. And once I got that understanding, it's actually quite simple, and it made everything easier when it came to working with dates and times. So we're going to start with the Date Time 101 section or intro, where we'll talk about the date value, which is kind of the key piece here, and why it's going to be your new best friend when it comes to working with dates and times in Excel. And talk date formatting, and then the fill series option, which is a nice little shortcut for creating sequential dates. We'll go into today and now, which are volatile functions that return the current date and the exact current time. We'll talk year, month, day, hour, minute, and second, which are great ways to kind of categorize your date data. We'll talk end of month and year frac. Go into weekday, workday, network days. Those are cool tips to kind of show how many work days fall between two dates, what date falls a certain number of work days from today, and so on and so forth. And then we'll finish with DATEDIF, which is another tool to calculate differences between two dates, and then wrap up with a very useful hands-on demo where I'm going to show you how to build your own budget pacing tool, which you can customize and transform into anything you want. 2 files for download. Got our Excel for Analysts Date Time Functions PDF and our Section 7 Date Time Functions Excel file, which we'll be walking through as we move through the lectures. So go ahead and download those 2 files. You can print them out if you choose. And let's dive right in. All right, so first and foremost, I want to talk about something called the date value. If there's one lecture you're going to listen to or one slide that you're going to read in this entire section, this is the one to pay attention to. And it's because the date value is the critical piece that allows Excel to process dates and times. So every date, in fact, every moment in time in Excel has an associated underlying numerical date value. That's how Excel is able to do things like calculate the passage of time or apply statistical functions to dates. Without those date values, dates would kind of just be treated like text fields. You wouldn't really be able to do much in terms of manipulation with those dates. So, midnight on January 1st, 1900 is treated as, I guess, the beginning of time in Excel's universe. So, January 1st, 1900 has an underlying date value of 1, and then every subsequent day beyond January 1st, 1900 has a date value 1 number higher. So, January 2nd, 1900 has a date value of 2, and so on and so forth. So Excel's actually really, really smart about dates, and then it recognizes most type dates and automatically applies a common date format. In most cases, it will be month/day/year with 4 digits, along with its associated date value. Now, the way to check if your entry is recognized as a date is to right-click, go into cell format, and switch to general, and it will show you if there's an underlying date value. So I'll show you an example of that right now. If I jump into just a blank workbook here, I'm going to type in a date by hand. I'm going to do January 1st, 2015, press enter, and now if I right-click A1, go into format cells. As you can see, it defaults to the date field. This is the default version, day, month, year. But if I switch to the general category, you can see that it has an underlying value of 42,005 because it's the day that's fallen 42,005 days after January 1st, 1900. So that tells me that, okay, Excel has recognized my entry as a date. I can treat it as such. It's also pretty good about understanding kind of strangely formatted ones. So I could say like 01-01-15, and you can see that it switched it over to the default version because it knew I was trying to type a date. You can actually get like a little bit weird with it. I like to kind of test to see how strange I can get. See, even that version where I typed it as, dash and combination of dashes and slashes, it still recognized it as a date, and it still applied that date value to it. So Excel is actually pretty smart when it comes to those things. And that's kind of the core reason why you're able to do such interesting manipulations and calculations against dates. So if you happen to type a date that Excel doesn't recognize, one common example that I've seen is if you type a series of numbers like date, month, day. So for January 1st, 2015, again, if you typed 2015-0101 with no dashes or slashes, Excel would not recognize that as a date, and so it wouldn't apply an underlying date value, and it would treat it as a text string, or in this case, value. So if that's the case, like if I download some data and the date field is in a very strange format like that, I'll show you how to use tools like date value or time value to convert those unformatted dates into formats that Excel understands. So looking at some examples down here, again, January 1st, 1900 is date 1, so date value equals 1. 10 days later on the 11th in 1900 would have a date value of 11. February 6th is 42,041 days after January 1st, 1900, and these date values don't have to be whole numbers. In fact, 42,041.5 equates to noon on February 6th, whereas 42,041.75 equates to 6 p.m., which is 75% of the way through the day. So you can get very granular, even down to the second. And that's how you can start working with very particular times in Excel, not just whole dates. So hopefully that helps. Once you understand this concept of date value, suddenly everything becomes a bit more clear when we start talking about actually manipulating and applying functions to these dates. So we just want to cover two more tips and concepts before we dive into the functions themselves. The first is date formatting. So when you format dates in Excel, you have a few options. You can either select a preset option from the date category in the Format Cells dialog box, which you can access just by right-clicking a cell and choosing cell formatting. Or you have the option to create your own custom format. So the preset formats, again, live in the date line or the date category of the Format Cells dialog box. And there are a number of options. Apologize, it's a little bit tricky to read, but you could scroll down and you could display your date with a number of different variations. You could show just the day and the month, not the year. You can show it as a 2-digit year versus 4. You could write out the day and leave the year as a number. Like, there are dozens and dozens of ways to show it, and probably has what you need. The other option is to jump down to the custom category and write your own formats here. So here are the codes that you can use. This is just a sample of them. The full list is available at support.office.com. But this just allows you to display a date in other additional ways. So, for instance, if I have a date in a cell, like January 1st, 2015, and instead of showing the whole date, I just want to show what day of the week that is, I could format that cell with a custom format, DDDD, and it will display the value as Saturday or Friday or Wednesday. I don't know off the top of my head what day of the week that was, but important to note that it won't change the underlying value itself. It will only change how you're displaying it. Second thing I want to show you is fill series, which is a great shortcut that Excel uses to basically help you populate a series of dates without having to manually type in sequential days or months or years. So let's say I wrote 1/1/2015 in cell A1 here. Excel has recognized it as a date. If I grab the lower right corner of that cell and drag it down to A5, by default, Excel is going to assume that I want to show it as day over day trending. So basically adding a day for each row. If I say, no, I don't want to do that, I just want to copy 1/1/2015 in every cell, I can click on this little button that pops up after you've dragged the values. And I can check copy cells, you'll see that it's defaulted to fill series, which assumes I want day over day over day. And then I have some other options here as well. I can fill only the formatting from cell A1. I could fill it without the formatting, or if I wanted to show the sequence at a level other than day, I have those options as well. So I can say, okay, rather than going in increments of days, let's show it in increments of months, in which case this would be 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, or years, in which case it would be 1, 1, 2015, 2016, 17, 18, 19, or even weekdays. So I can say increase the date by 1 day per cell, but exclude weekends. So this is a really cool way to create rolling date windows or automate a lot of the process when you're working with date-focused data sets that are constantly changing. So keep these two tricks in mind. We're going to be using them quite a bit in some of the upcoming exercises. All right, the first two date and time functions that I want to share with you are today and now, which are designed to simply return the current date or the current exact time. And the good news is that these are perhaps two of the simplest functions in Excel, and they're so simple because they actually don't even refer to other cells. You just open and close your parentheses, don't even put anything inside, call it a day, and you're good to go. Important to note that these are volatile functions, meaning that they will update any time you make any worksheet change in any open workbook, so they'll be constantly changing. Let's jump into Excel and go ahead and open up section 7, date time functions. I'll do a quick walkthrough. As you can see on the first tab, date time functions, we've got a placeholder for the current date and current time, which we're going to populate in just a minute using today and now. We also have a hypothetical project due date, which we'll get to later. And then this is basically where we're going to practice all the functions that we learn in the upcoming lectures. The second tab is a blank budget pacing tool. This is the demo that we're going to walk through at the end of this section, where we're going to work together and use these date and time functions to build out a custom budget pacing tool. And then last but not least, on the third tab called sample data, we just have a series of dates and expenses, and these are going to feed into the budget pacing tool that we build. So jumping back to date time functions on tab 1, let's just populate these today and now functions in cells C2 and C3. So for current date, I'm just going to type equals today, open, close, enter. So it returns the current date, which is August 18th, 2015. Current time, same process, equals now, open, close, press enter. And as you can see, they're returning the same thing, except current time, or the now function, is just a bit more granular. That will introduce the hour, minute, and second components that the current date or today function will not. So there you go, extremely simple, but this is going to be our starting point to practice the functions in the upcoming lectures. So Excel will always calculate dates and times based on their precise underlying serial values, or date values. But what if you need to work with less specific values? So what if you don't care about the specific day, you just care about the month or the year, or even the hour or the minute? If you need to roll up your data in a less granular way and view things at a higher level, there are a number of serialization formulas that allow you to do that. So the most common ones include year, month, and day, and hour, minute, and second. Basically, all they do is extract those individual components out of a given date. So syntax-wise, they're about as easy as it gets. They're written exactly as you'd expect. So year is year, month is month, day is day, and so on. And the only actual component of the formula is the reference to a cell containing a date or time. So let's jump into Excel and write some of these. What I'm going to do is populate cells C5 through C10 to extract year, month, day, hour, minute, and second out of our current date and time fields. So current year, it's just going to be equals year, and the serial number or reference could be either C2 or C3 in this case. So if I start with C2, close it off, you'll see that it extracts 2015 because that's the date of the current day. I could also change the reference. I'm going to show you a little shortcut here. Rather than going in and changing this and typing C3, Obviously, that wouldn't be very difficult, but what I'm going to do instead is press F2 to dive in, and then just grab my reference and drag it down to C3 and press Enter. That will accomplish the exact same thing. So moving on to month. Same story here. Do month of C3. Day of C3. So that's telling me we're in the 8th month and the 18th day of the month. Now, for hour, minute, and second, I have to refer to the now function because the today function doesn't give me that level of detail. So if I tried to do hour of C2, it's just going to give me a 0 because there's no hour specified coming out of that formula. So what I'll do, again, is just change the reference, drag it down. And now it's telling me I'm in the 12th hour of the day. For minute, again, refer to C3, 30th minute, and finally, second of C3 is 16. And again, because these are volatile functions, you can watch them change anytime you make any workbook update. So if I type some values in here, see that second value changing. Or if I went into the Formulas tab, I can press this Calculate Now button and watch the seconds tick away. So there you go. It's a very simple but very valuable way to extract specific components of a date. Next up, we have the end of month or EO month function, which calculates the last day of a given month. It can also be used to calculate start or end dates of previous or future months as well. So the syntax-wise, just two components in this formula. It starts with your start date. That can be a current date. It can be a random date. It can be any cell reference to a cell containing a date, and then the months component, which is the number of months before or after your start or current date. So if I'm interested in the last day of the current month, I would put a 0 for months here. If I'm interested in the last date of next month, I would put a +1. If I was looking for the last date of the previous month, I'd put a -1, and so on and so forth. So let's say we've got a start date or current date of 8/3/2015 in cell C2 here. We can use the EO month function in a number of ways. If we want to calculate the end of the current month, we would use EO month C2, 0. To calculate the start of the month, you have to get a little bit clever, but you can use the EO month function to do that. So, for instance, the start of the current month could be calculated using EO month C2, -1, which gives me the last date in the previous month, and then just add 1 to get the first date of the current month. So remember that dates really are just values because of that underlying date value. So adding 1 to it essentially just tacks on 1 day. So similar case here, to get the start date of the next month, we can say EO month C2, 0 to get the last day of this month, and then add 1 to get the start date of the following month. So let's jump over to Excel and actually practice this. For a last day of the month in cell C12, all I need to do is write equals EO month. And then my start date, or cell reference to a date, could be C2 or C3. I'm just going to choose C2 here. And what I'm going to do is press F4 to fix that reference, which will give me the option to copy and paste this formula elsewhere, while continuing to refer to C2, so I don't want that reference to shift on me. Comma over to the next piece, which is months, and in this case, I'd like the last day of the current month, so I'm just going to put a 0 there, close the parenthesis, and press Enter. So the result is 42247, and if you paid attention to the first few lectures, you'll probably recognize that this is a date value that it's showing me. And that means that this cell is formatted with the general formatting type. So all I can do is right-click, go into Format Cells, change it to Date, and then select any option that I choose here. So I'm going to go with the default month, day, year option, press OK. And there we go, 8/31/2015. Keep in mind that depending on when you're actually doing these exercises, you're going to see different values and dates here than I am. Don't worry about that. The concepts and fundamentals should still apply in any case. So to get the first day of the month, I'm actually going to copy this formula, paste it down, And now remember the little trick. Instead of 0, which applies to the current month, I want the last date in the previous month. So I'm going to put -1, and then I'm going to jump outside of the parenthesis and add one more day to it, which will get me to the first day of the current month, which is 8/1/2015. So now, last but not least, first day of year. This one's a little bit trickier. There are a couple ways to do it. The first way is to just copy and paste that same formula that I just wrote. But instead of looking 1 month in the past, I'm going to look 8 months in the past, because the current month is August, or 8. So this will get me the last day of December of last year. And then I'm going to add 1, which should return the first day of this current year. So I press enter. That seemed to work, so I got 1/1/2015. Now, when you're doing it at home, you may not subtract 8 months depending on what month you're looking at. So we can modify this formula to make it work no matter what your current date and current time is. And to do that, I'm going to just replace the -8 here. So what I need to do is subtract the current month number, which requires me to know what the month number is and then multiply it by -1 to get the right month component for this formula. So in parentheses, I'm going to do -1 times month of current date, and then close off all of those parentheses. So to recap what I just did, now what I'm saying is I want the end of the month where my current date or starting point is C2, but the number of months that I want to look back in time is a function of what my current month is. So this is saying if I'm currently in month 8 of the year, I want to go back in time 8 months and get me the last day from 8 months ago. If I'm in the 10th month of the year, I want to jump back and get the last date from 10 months ago, and so on and so forth. And then again, this last piece is just to tack on that 1 extra day to get the first of the following month. So if we press enter, there you go, we get the same response, 1/1/2015, and that will now return the first day of the year, regardless of what your current date and time is. So, as you can see, EO month is a really useful function. You can use it to do a number of very creative things, and it's a pretty critical tool for Excel users working with dates and times, because there's really no simpler way to do it, given the fact that the number of days per month varies. This kind of automates a lot of that tedious manual work that you'd have to do otherwise. So there you go, EO month function. So the next function I want to talk about is called year frac, which calculates the fraction of a year represented by the difference between two dates. So typically this is used to compare the first date of a given year versus the current date to show what percentage of the year you are through. But you can do it for any two dates and look at basically any window you choose. So syntax-wise, 3 components to this formula. You've got your start date, your end date, and your basis. Basis just allows you to specify the type of day count to use, or in other words, how you're defining the number of days in a year. 0 is the default. I'd actually recommend putting a 1 here, which looks at the actual number of days in the actual year that you're in based on your start and end dates. So that will account for things like leap years, which might have 1 additional day, 366 versus 365 for the year before or the year after. So here's an example. If you've got a start date in cell B2, 1/1/2015, and an end date in cell B3, 2/28/2015, here are 2 example outputs. In the first case, we're using the 1 basis, which is actuals, and that's telling us that on February 28th, 2015, we are 15.9% of the way through the year, and that's through the actual year, 2015. If we change the basis to 2, that percentage changes slightly to 16.1 because now it's based on a 360 year basis. So pro tip here, yearfrac is a really great tool for things like pacing and projection calculations. So let's take a look at Excel. Basically, we're just going to use the data that we've already input here to calculate the percent through the year of our current date. So I'm going to do equals yearfrac, open the parenthesis, our start date I'm going to use the first day of the year, which we calculated in the last lecture, and then the end date in C2, and then my basis is going to be 1. And when I close that out, I get 63%. So that's telling me that today, on the 18th of August, I'm 63% of the way through the year. So there you go, year frac. All right, so let's talk about 3 more date functions. We're going to talk weekday, workday, and network days. So starting with weekday, really valuable one. It shows you which day of the week a given date falls on. And there are 2 ways you can do this. The first is just to use a custom cell format like we talked about in Lecture 2. So you can use either 3 Ds to get an abbreviated day of week or 4 Ds to get the full day of week. And again, note that this isn't actually changing the value or creating any kind of new value. It's only changing how the original date value is being displayed to you. The second, which is the approach that I'd recommend, is using the weekday function, which actually returns a serial value corresponding to a particular day of the week, either 1 through 7 or 0 through 6. So the syntax is pretty simple. You've got your serial number first, which is the cell that contains a date or a time, and then your return type, which is optional, or 0 is your default, which assigns a number 1 to a Sunday, up to number 7, which is Saturday. If you prefer to call Monday the start of the week and assign 1 to Monday, you could put a 1 here instead of a 0, or instead of leaving it blank. So a really useful function, especially when it comes to doing things like day of week analyses, where you want to see how performance or data differs on a Tuesday versus a Friday versus a Wednesday, and so on. Workday and network days. So workday, to be totally honest, is a little bit confusing. Basically, it returns a date that is a specified number of days before or after a given start date, excluding weekends and holidays if you choose to add those. So the most common application that I can think of is to say, what date falls 50 work days from today? So once I get through 50 work days, which doesn't include weekends, what date am I going to land on? And so syntax-wise, it starts with your start date, then goes to the number of days. You can either put a positive value here if you want to look forward in the future, or a negative value if you want to look back in the past. Those are all the required components. There's an optional holidays component that lets you reference a list of holidays, and it will essentially exclude those from the number of working days that it's calculating. So that's workday. Network day, which I actually find much more useful and more practical, shows you the number of workdays between 2 dates. So you input a start date, an end date, and an optional reference to a list of holidays, and it will tell you how many workdays or working days fell between those dates. So 2 examples here. I've got the same 2 date references that I mentioned in the last lecture, which are January 1st, 2015 as our start, February 28th, 2015 as our end. So if we say workday B2, 20, that's saying from the start date of January 1st, 2015, what date falls 20 workdays after that? And it will return the date January 29th, 2015. If we use the network days function and set B2 as our start date and B3 as our end date, it will tell us that between January 1st and February 28th, 2015, there were 42 working days, which is the total number of days minus all of the weekends. So let's jump into Excel and see kind of how this works in practice. So in F3, I've got a project due date cell, and I'm just going to make up some date far in the future. That means nothing. So let's say May 9th, 2017. This is a big project, and it's going to take a lot of time. Days until due. This is really simple, since date values are really just values that I can perform any normal operation on, just like I would any other numbers. I'm just going to say the due date minus the current date. Now, it turns 630, so I have 630 days between August 18th, 2015, and May 9, 2017. So that's the total days until due. Now, if I want the number of work days until due, because obviously I'm not going to spend my weekends working on this project, I can use net work days. So net work days. Start date is current date, 8/18. End date is the due date. So if I leave the optional holidays field blank, close the parentheses, and press enter, that's telling me that, well, I have 630 total days until it's due. I only have 451 working days until it's due. So for the holidays piece, what I can't do is just type in a number of holidays, like 5, and say, okay, exclude those 5 holidays. And it'll just return the same value of 451. What it needs here is an actual reference to a list of dates that define the holidays that I want to exclude. So what I can do, just for the sake of an example, let's say 12/25, 2015, I want to take off Christmas, and I want to take off January 1st, 2016, and those are the 2 holidays between today's date and May 9th, 2017, that I plan to take off and not work. So what I can do is say, okay, instead of putting a 5 there, I'm going to refer to H5 through A6, which is my list of holiday dates, and press enter. And now you can see it updated to 449, so it excluded these holiday dates as well. Note that if you have a holiday that also falls on a weekend, it would have already been excluded here. But in this case, both of these dates are weekdays, so they were being counted in the 451 total. And so when I add that reference in, it excludes those 2 and leaves me with 449 working days until the project is due. Last but not least, for day of week, again, I could just right-click and go into Format Cells on the actual date field and say, let's just do a custom delete this type line and put DDDD. Say, okay, it's a Tuesday, but I want to continue to show the date in its current format and just add the day of week separately here. So I'm going to use the weekday function equals weekday of the serial number, which is F3. And I'm going to leave the return type default. So I get a 3. And when I format the 3, I can change that to custom DDDD. And there you go, it gives me Tuesday. So May 9th, 2017 is a Tuesday. So there you go. There's weekday, workday, and network days. So the last function that I want to talk about in this section is called DATEDIF, and it calculates the number of days, months, or years between 2 given dates. So 3 components of the formula syntax. Starts with the start date, then you input an end date. The third piece is the unit. So this is determining how you want to calculate the difference between the 2 days. You can set it D here to calculate it as the number of days between the dates. M would return the number of months between dates. Y would return the number of years between dates. There are also options like MD, YD, or YM, which will calculate these differences regardless of months or regardless of years. So 2 examples here. Again, we're looking at the same start and end dates that we used in the previous 2 examples. January 1st, 2015 is our start. February 28th, 2015 is our end. So if we set the date diff between our start date in B2 and our end date in B3 and set the unit to days, it will return 58 since there are 58 days between these dates. And note that this is functioning kind of like a network days function, except the network days is excluding weekends. This is returning all of the dates. And also note that this is doing the exact same thing as just writing the formula B3 minus B2. So, pro tip, if you only need to calculate the number of days between dates, just use simple subtraction. You don't need to use a DATEDIF function for that. But where the DATEDIF function becomes much more valuable and where it can't be replicated using simple operations is if you want to calculate the difference in terms of months or years or so on and so forth. So if we want to say DATEDIF between January 1st and February 28th with the MD unit, which is the number of days between dates, ignoring months and years, it's going to say there are 27 days between the 28th and the 1st, regardless if I'm looking at a different month or a different year. So let's take a look at Excel and practice this. So to revisit this project due date that we'd written in the last lecture, what I can do here is if I want to calculate the months remaining until my project is due, I can type equals DATEDIF. And then, I don't know why this is the case, but Excel doesn't help you through this function. It just kind of leaves you hanging. Not sure if it's a bug or what, but if we rely on our memory, we know that the first component of the DATEDIF is the start date, which is my current date. And then the end date is going to be the due date. And then the last piece is the unit, remember. So in this case, I need the month remaining. So I'm going to put an M in quotes. And this won't work unless I put the M in quotes here. So just keep that in mind. And then when I hit enter, that tells me that I have 20 months remaining from the current date through the date that my project is due. And then similar case here, what I'll do instead of writing this from scratch, I'm just going to fix the references in my original function. So fix the C2 and fix the F3. Copy that formula, paste it down, and change the M to a Y since I want the years remaining. So it's telling me that I've 1 year remaining until my project is due. I could also jump back to cell F5 where I'd calculated my days until due as just F3 minus C2. And let's see if we can get the same answer, 630, using a DATEDIF function. So I'm going to do DATEDIF C2, comma, F3, comma, D in quotes. And there you go, 630. So again, two ways to do the same thing. And I don't know about you, but I would prefer to just say F3 minus C2 and call it a day. But DATEDIF can be a great option, especially if you want to aggregate the difference between two dates at the month or year level. All right, welcome to the end of section 7. Congrats on making it through. We talked about a ton of different useful date and time functions, and now it's time to put some of them into practice. So what we're going to do is kind of step-by-step walk through this project that incorporates a bunch of the different date and time functions in tandem with some of the functions that we learned earlier in our training. So let's do it. First thing we need is the current date in C2. And contrary to what you might be thinking, I actually don't want to use the today function here. It's a little bit misleading, but I don't want to return what day it is today. I want to return the latest day in my data set. So if you recall, the sample data has expense data by day, going down to May 16th. So if I don't have expense data after that, and I type today, which is in August, this tool isn't going to be very useful. So instead, I'm going to use a max function. I just want to return the max date from column A of my sample data tab. Now it will return 5/16. The other benefit of doing this is that when you're working through this exercise on your own at home and you use the today function, it's not going to jive with the sample data and it won't really make much sense. So for now, just use the max function. And if you do end up building one of these or customizing one of these for your own use, you can change it as you see fit. So start date is going to be the first day of the current month. And again, current meaning latest data in our data set. So I'm going to use the EO month function here. Start date is going to be C2. And remember that to get the first date of the current month, I need to take the last date of the previous month. So -1 plus 1 day. Now it gives me 5/1/2015, which is exactly what I want. Now for a percent of month, this one seems like it should be really easy, but it's actually a little trickier than you would think, because there's really no month frac function. Year frac is really useful because you can just say, tell me the percentage through the year that I am. There isn't an equivalent for month frac, and the challenge is that each month has a different number of days. So I know that I'm 15 days of the way through May, but do I divide that by 30 days or 31 or 29? So what we need is a useful little table, which I've conveniently added in here, in cells B24 through C35, which tells me the number of days in each month based on the month number. Now, so I can use that to calculate my percent of month field. equals my current date minus my start date. I'm going to surround that piece in parentheses. So that's the number of days through the month I currently am. And I'm going to divide that by the total number of days in the month. To get that, I need to use a VLOOKUP function. And the lookup value is going to be the current month, which is the month of my current date. So month of C2 will just return 5. And 5 is the lookup value that I'm looking for in this table array. So it's going to look for 5, and then I want to return the value in the second column over, because that's where my number of days live. And then it's going to be an exact match, so I'll finish it with a 0, close the parenthesis, and hit Enter. Now I'll return 48.4%, telling me that on the 16th of May, I was 48.4% of the way through the month. And again, just to recap what this formula is doing, it's calculating the number of days I've gone through May, divided by the number of days in May, and it finds that by searching for the month at my current date down in this table array and returning the value in the second column over. So that's that piece. The next piece is all about my monthly budget and my monthly expenses. So the monthly budget is a user-entered figure, and that's whatever you want. So let's say our monthly budget is $2,500. That's just kind of set in stone. Now, to calculate monthly expenses, there's one step we need to take. Because our expense data is at the daily level, and we're looking to roll it up at the monthly level. So we need to create a new column, column A, called month, that rolls this data up at the month level. So it's just going to equal month of the date, B2, and then apply down. And that will show me, okay, month number 1 for all the January dates, 2 for February, 3 for March, 4 for April, and 5 through May. And now that I have this additional dimension, I can use a SUMIFS formula to roll up my expense totals at the month level, not just at the day level. So, if you recall the SUMIFS from the statistical functions section, we're just going to start with SUMIFS, open parenthesis, and then the sum range. It's basically where the data lives that I'm trying to aggregate, which is the expenses column, column C, my sample data tab. And then the criteria range is basically the month number, because that's the criteria that it needs to meet to aggregate these expense totals. So the criteria range is column A, and my criteria is the month of the current date. So remember, what I'm going to need is a function that will return the number 5 here. And so it's just going to be month of monthly budget pacing tool, cell C2. And then close those two parentheses, and there you go. So when I hit Enter, it returns 1603, which is telling me that all of the expense data in the month of May is totaling to $1,630. I can check that by scrolling down to the May data and just looking at the sum. 1603, so that's working properly. If I wanted to make these formulas a little bit easier, what I could also do is just in another cell, I could just write that month function to return the 5. And then in my SUMIFS, rather than nesting the month function there, I can just basically refer to that cell where I've already put the month function and get the same response. So a few different ways to do it. It kind of depends on specifically what you're looking to do. And now percent of budget is just going to be what I've spent divided by what my budget is, so 64.1%. Now here you'll see that I've added the framework for a chart. So click on that, and we're going to do right-click to select the data. And I know this training isn't on charts and graphs, so apologies if this is tough to follow. I will be putting out a course specifically covering charts and graphs in the near future, so stay tuned for that. But in the meantime, just try to follow along step by step as we build this out. So I'm going to add a series. The series name is going to be called percent of month. And the series values is just going to be cell C4, which is telling me the percent of the month. Hit OK, and add one more series. The name of this series is going to be percent of budget. And the series values is just going to be cell F4. Hit OK. And then I hit OK again. As you can see, it's created a chart for me that's showing the percent of budget shown in orange and the percent of month shown in blue. Now, one more piece that I'm going to do here in this cell, I have a merged cell in each two. What I'm going to do is basically just calculate the difference between the two percentages. So it's just going to be equal to F4 minus C4. So that's telling me that I've spent 15.7 percentage points above what I'm pacing for the month. So what I can do now, just to add some bells and whistles, is go into conditional formatting, highlight cell rules, and say, okay, if this number is greater than 0, it means percent of budget is greater than percent of month, meaning we're overpacing, which is a bad thing. I'll format that with light red fill with dark red text, which is one of the default options, and hit OK. And then I'll also add a rule where if it's less than 0, meaning we're underpacing, we'll do green fill with dark green text and hit OK. So now if my monthly budget was $5,000, now all of a sudden I'm underpacing by 16.3 percentage points. So you can kind of play with it, to see how the chart updates. And then last but not least, if I wanted to, add some more flair to it, I could add a logical operator here that says, so equals if each 2 is greater than 0, then I want this to say overpacing, otherwise underpacing, close the parenthesis. So that will just add a little label there under my conditionally formatted cell, show me, all right, I'm underpacing now, but if my budget again was $2,500, now I'm overpacing. So there you go. It's a great example of how to combine a number of different functions from a number of different formula categories to create something that's actually useful. Last thing to speak to is that this tool is great because it will update kind of on its own as you add more data. So let's say like another week goes by. You can drag this down. And as you can see, the fill series defaulted to adding days for each row. I can just drag my month formula down and then say, okay, I spent $90 on the 17th, $114 on the 18th, and $75 on the 19th. And when I jump back to my tool, as you can see, it's updated. So now the current date is the 19th, since it's a max function. I'm 58.1%, and I'm 75.3% through my budget, factoring in those additional days that I just added. So we spent some time building out the front end, but now it's pretty much automated to use very easily moving forward. So that wraps up date and time functions. I hope you found it useful. Stay tuned for the next section, which is formula-based formatting rules. All right, congrats on wrapping up section 7, date and time functions. If you want to get some extra practice in, got some good demos for you in the Excel homework exercise file. So go ahead and open it up, head to the date and time functions tab. And here we've got 7 steps. Essentially, you're going to practice using all the functions we covered in this chapter: today, now, weekday, workday, network day, end of month, and fill series. So go ahead and give that a shot. Answer file is available in the course resources, or just shoot me a message if you need support. Good luck. Hey everyone, welcome to section 8, formula-based formatting. This section's a little bit different because rather than covering a new category of formulas and learning new functions and syntax, we're actually going to be using the formulas we've already learned in a new context, in this case, to create custom formula-based formatting rules. So we're going to start with just a quick section on creating and editing your formatting rules. Then we're going to go into a series of demos. Demo 1 is about highlighting every other row using the mod function. The second demo is going to cover formatting cells based on the value of another cell, which is a very useful one. The third demo is going to be about formatting rows using statistical functions. And last but not least, I'll show you how to format rows using text functions. And these are just some examples. The beauty of this is that just like there's an infinite number of ways to use the formulas we've learned, we can also apply those formulas to an infinite number of custom formatting options. So really cool, creative things that you can do here. And last but not least, as always, 2 files to download. Got our Excel for Analysts Formula Formatting PDF file. Go ahead and print that out. And then the Section 8 Formula Formatting Excel file. So again, this is going to be a really hands-on section. A lot of working with Excel, so go ahead and open that up, get yourself familiar, and let's go. So I want to take a minute to talk about conditional formatting in Excel. It's one of my favorite things. I love conditional formatting because once you learn it, it's pretty easy to do and it absolutely blows people away. I swear, you just slap a color scale on a column and people will think you're an absolute rock star. So many of you are probably familiar with the stock conditional formatting rules, cell highlighting rules, or data bars, color scales, icon sets. That's all great, it's all well and good, but let's leave that for the children. Let's talk about how to go rogue and actually create our own conditional formats. And let's do it using formula-based rules. This is kind of one of those next-level Excel tricks that really opens the door to do some pretty incredible things. So first off, just want to cover creating and editing those formula-based rules. Basically, in the Home tab, if you click the conditional formatting drop-down, you'll see this menu here on the left. The first 5 options here are those kind of basic stock conditional formatting rules that we're going to leave for another time. These 3 options down here, this is our sandbox. This is where we're going to play. So you can just create a new rule here, and this little pop-up box will show up. And what we're interested in is this last option here under the Select a Rule Type window. Use a formula to determine which cells to format. So once we click that, this window appears here. And this is where we write our formula, so it's a little bit trickier because we don't get the little helper box to guide us through. But at this point, I mean, we're in Section 8. You guys should be experts by now. We're going to have to rely on our intellect and our memory and our pure instinct, so this is going to be fun. So this is where you write your formula, which is basically saying, if this formula is true, then I want to format the cells as such. So you'll click the Format button, choose your options, your fill, your border, your font, all that good stuff, and then press OK. So here we've showcased just one example of a formula-based formatting rule. In this example, we're formatting the cells in columns B through H with a green fill and a bold font, but only when the state name is equal to the value in cell C2, which is this drop-down cell up here. So one thing to note is that when you're working with formula-based formatting rules, the reference types become incredibly important. So understanding when to use fixed versus when to use relative references is critical. So we're going to spend a lot of time talking about that. So let's hop over to Excel and actually see what this looks like. I've opened up the Section 8 Formula Formatting Excel file. Go ahead and do the same thing. Let's take a look at what we're working with. 2 tabs here. The first should look familiar. This is our price checker example that we built out during the lookup reference section, particularly when recovering the index and match functions. Second tab is called State Data. This is just some raw state and year level data showing total population and student population. So these are the 2 tabs that we're going to be using for the demos in the upcoming lectures. So if I want to create a new formula-based formatting rule, first thing I want to do is select the cells where I want the rule to be applied. So in this case, I'll just select C3 through G7, click the Home tab, Conditional Formatting drop-down, New Rule, use a formula to determine which cells to format. And then here's where I'm going to type my formula. And then once that's written, I'm going to click Format, and here's where I'm going to select my actual format to apply when my formula is true. So cancel out of that. And then once I have rules written, I'm just going to go into conditional formatting again, go into Manage Rules, and then I can either look at rules for the current selection, which right now is cell H10, or I can say, show me all the rules in this current worksheet. And right now there are no rules applied, but as we start writing them, you'll see this list start to populate. And this is where you can edit your rules, you can edit the formulas, Within your rules, you can edit the formatting settings, or you can delete your rules altogether. So there you go. Let's get ready for demo number 1. All right, let's go ahead and dive into our first demo. So go ahead and open up the Section 8 Excel file. We're going to start on State Data tab. And our challenge is going to be to create a formula-based formatting rule that highlights every other row in this data array here. So I may have lied in the last lecture when I said that you've learned all the formulas you need to use for this. We're going to learn one more, and it's called mod, M-O-D. And all that mod does is returns the remainder when you divide one number by another. So, for example, if I type equals mod, and then you'll see that this is pretty simple formula, only 2 components, the number and your divisor. So if I put a 4 and a 2, close it out, I'll get a 0 because 4 divides evenly into 2. If I change that 4 to a 5, now I get a remainder of 1 because any odd number divided by 2 will return a remainder of 1. So that's the mod function, and that's going to be a critical piece to creating this formula-based formatting rule. So first step is to create the data array that I want this rule to be applied to. In this case, I'm going to select A2, Control-Shift-Arrow down to D52, so I've got my whole array selected. Now on the Home tab, I'm going to hit the Conditional Formatting drop-down, create a new rule, use a formula to determine which cells to format. So every formula-based formatting rule starts with the equal sign. I'm just going to start with my mod function. And you can see how Excel's not really helping me along here, kind of on my own. So make sure you know exactly how your formula syntax looks before you jump into this step. So first piece of the mod is my first number. And that number is just going to be the row function with an open and close parenthesis. And that's basically going to go down and say for each sequential row, let's see what the row number is, and the second number is going to be 2. So basically what I'm doing is simple division problem, where I'm dividing the current row number, row by row, divided by 2, and the last piece of this function is going to be equals 1. So again, dividing the current row number by 2 and checking when the remainder is 1. In other words, this is going to impact only odd rows. And when that's the case, I'm going to choose the formatting that I want to apply. So I'll press Format. And in this case, all I really want is a light green fill. So I could also go into border or font. In this case, just a green fill will do just fine. So as soon as I press OK, I go back here, I'll press OK one more time. And there you go. The rule has been applied. And as you can see, it's applying the custom formatting to each odd row, because when each odd number is divided by 2, it returns a 1. So that seems to be working properly. And now if we wanted to edit this rule, just go back into Conditional Formatting, Manage Rules. There's my rule, and I click Edit. And now if I change this to 0, I should see the same formatting applied to the even rows, because in those cases, the mod function will return a 0 because there's no remainder. So I'll press OK again, and now I'll just hit this Apply button here. And there you go, you see the formatting shift up to only the even rows. Last but not least, if I want to delete this, you could press Delete and Apply, and now it's gone. So there you go, highlighting every other row using a combination of the mod and row functions. All right, so let's get started on demo number 2. Formatting cells based on the value of another cell. And this is a fun one, and it's a really useful one just because there are so many opportunities to apply similar rules in all sorts of different contexts. So in this example, we're going to be using the price checker that we built during the lookup and reference section. And if you recall, we used an index match function to return a price from a certain array, in this case C3 through G7, based on selections for product and size. So what we want to do here is create a custom formatting rule that searches for the selected price in E10 and highlights it in the array from C3 through G7. So what we're going to do is start by just selecting the array that we want the rule to be applied to. Go into Home, Conditional Formatting, New Rule. We're going to use a formula to determine which cells to format. And now, as always, we're going to start with an equals. I'm just going to select the top left cell in my array. So cell C3, I set that equal to cell E10. And I'm going to leave it like this for now, just to show you what happens if we leave the references fixed. So in the case of this formula is true, what formatting do we want to apply? Well, let's choose a nice bright yellow and a bold font just to make the selection pop. So when I press OK, that will apply the rule. And as you can see, nothing's happened. So right now we have extra small sweater selected, which returns the price of $30. So in theory, we would expect cell C7 to be displaying the custom formatting rules that we just set. What happens if we choose extra small socks, which is $4, which sets cell E10 equal to C3? Now we're seeing the formatting rule applied to the entire array. And to understand what's going on, let's go back into conditional formatting, manage rules. There's nothing in our current selection, which is cell B10, so I need to change this to this worksheet. There's my rule. I'm going to select it and hit Edit. And so now, just thinking about what this rule is telling us, it's basically just saying, anytime that cell C3, and only C3 since it's fixed, is equal to cell E10, apply this formatting, and remember we're applying it to the entire array that we had selected. So Excel is actually doing its job, because in this case, when I have extra small socks selected, C3 does in fact equal E10, so this formatting rule is being applied. It's just not working quite how we want it to. And the key is to remove the fixed references here, which will allow the C3 to shift to any cell, any row, any column within the array that we've set. Now that's a relative reference. So now when I press OK and hit Apply, only the 4 is selected. And now to test this out, we can choose a number of different products and sizes and watch that highlighted cell shift accordingly. So there you go, just one example of formatting a cell based on the value of another cell. All right, so for this next demo, I want to show you some examples of how you can format cells based on statistical rules or functions. So let's jump back into the Section 8 Excel workbook, into the State Data tab. And the first example I want to show you is highlighting cells within a specific column that meet a certain value. So in this case, let's just highlight the cells where total population is greater than 5 million. To do that, I'm going to select C2, Control-Shift down to C52. I'm going to select Conditional Formatting, New Rule, Use a Formula. And now all I'm going to do is type equals C2 is greater than 5 million. Now the one piece that I need to change before I submit this is to convert the row reference from fixed to relative. So the C is okay. In fact, C is the only column in this array. But the row 2 needs to be relative because I need to check the population value in every row, not just row 2. So I'm going to delete the $sign there and then select my format. And let's just do kind of a light orangey shade here. Press OK. Now when I press OK, there you go, now that we see that. Just within this column that I've applied the rule to, all of the values above 5 million are now highlighted. I can also select the same range, go into Conditional Formatting. Let's add a new rule using a formula. This time, I'm going to say equals C2, again, making the row reference relative, equals the max of the entire column C. And what I want to do here is basically identify which row in column C is the maximum value and format it accordingly. So I'm going to choose a formatting rule. Let's go into border and let's give it a full outline border. Press OK. Press OK. Now, as you can see, the value of 33.8 million, which is California's population, is the greatest value in column C. Therefore, it's the only one that receives that formatting rule. So let's go ahead and go into Manage Rules, show the whole worksheet, and let's delete those two. And now what I want to show you is if we basically take the same rule, or total population is greater than 5 million, but rather than just highlighting the cells in column C, I want to highlight the entire row in which total population is greater than 5 million. What I can do is basically write the same rule, but before I do, select the entire array from A through D, rather than just C2 through C52. So again, conditional formatting, new rule, use a formula, and then same exact formula equals C2 with a relative row reference greater than 5 million. Format it with a light orange fill. And now, as you can see, we're still identifying the rows where total population is greater than 5 million. And the only difference is that in this case, the formatting is applied to the entire row, because when we created the formula-based formatting rule, our selection included all of the columns from A through D. And now we can go ahead and very easily edit this rule. So I'm going to go ahead and edit it. So let's say if we wanted to, rather than select rows where total population is greater than 5 million, if we wanted to select rows where total student population is greater than 5 million, I would just change the C to a D, press OK, and apply. And as you can see, there's only one state where the student population is greater than 5 million, and that was California. So last but not least, I can also create additional statistical formulas here. So rather than just checking, greater than or less than or equal to, I can edit and say, let's check if the ratio of students to total population, so D2 divided by C2 with a relative row reference, in parentheses, is greater than 25%, so 0.25. Now I press apply. As you can see, it's updated to include many more rows. And to check that, we can add a new column called student pop percentage, which is just equal to D, divided by C, format it as a percentage and apply it down. And then as you can see, only the rows that are greater than 25 have applied the formatting, so the rule seems to be working properly. So there you go, just a few examples of how you can use the statistical functions that we've covered as part of formula-based formatting rules. So for the final demonstration, I want to show you how you can format cells based on text functions as well as logical operators. So when I go back to the State Data tab, I've eliminated all of my existing rules, or I start from scratch. And the first thing I want to do is just highlight all the state names that begin with the letter I. So I'll select A2, Control-Shift down to A52. Conditional formatting, new rule, use a formula. And now since I want to return the value of the first character, I need to use a left function. So I'm going to type equals left, open the parenthesis, select A2, but allow the row reference to move, so I'll make it relative. And now one little side note here. You may have noticed that as I move through these formulas, I tend to click to choose different positions as opposed to using my keyboard arrows. That's because if you use the arrows, it kind of automatically tries to insert references for you, which can be really frustrating if you don't want references. So my recommendation is when you need to do things like change certain characters in a function, just use your mouse and your cursor to try to jump right into that piece of the function and edit it directly. You've probably already run across that issue and realized that it can be really frustrating sometimes. So little tip there. In any case, we're saying the left of A2, and the number of characters we're looking at is just 1, so we can do comma 1, close the parenthesis, equals the letter I in quotes. So that's it. So the function is left of A2, 1 character, equals I. And so when this formula is true, the format will be, let's say, bold with a blue background. Press OK. And there you go, it's highlighted Idaho, Illinois, Indiana, and Iowa. So, working properly. Now, one other tip, if you recall in the last lecture, we applied a function or a format to column C. And then in order to apply it to the entire row, we deleted it, made a new selection, and then rewrote the formula. This time around, I want to show you a quicker way to do the same thing. And to do it, I'm going to go into Manage Rules. I'm going to check this worksheet so I can see all of them. Select my rule, and then you see where it says Applies to A2 through A52. I'm just going to choose the selector, and I can either drag a new array out, or I can just click in and change the A to a D. And then when I hit Apply, it applies the formatting rule all the way out through column D, as opposed to just column A. So a much quicker way to do the same thing. So that's the first rule. Now, what if we wanted to get a little bit more complicated and insert some logical operators in here? So what I want to do now is say, let's highlight the rows where the state name starts with an I and ends with an A, so where both those conditions are true. So I'll manage my rules, go into edit this one, and if you recall that one criteria 1 and 2 need to be true, I need to use an AND statement. So I'm going to start right after the equal sign, type my AND, open the parenthesis. The left function is condition 1, and I press comma to get to condition 2. And so if my first condition is that the leftmost character is I, the second condition that I need to meet is that the rightmost character is A. So we use a right function here. Same reference here, I'll just do A2, and I can either go up and select the A2 and then delete the $sign. Or, I can just type this by hand as well. It's pretty simple. A2, and then the single rightmost character. Close the parenthesis. Oops. Equals. And then lowercase a, in quotes, close the parenthesis, and now have an AND statement that includes two components. Leftmost one character equals I, and the rightmost one character equals lowercase a. So I've hit OK and apply. As you can see, the formatting is now only applying to the two states which meet this criteria, Indiana and Iowa. So just a few random examples, but again, a virtually infinite number of applications for this kind of stuff. So that wraps up the formula-based conditional formatting section. Feel free to reach out if you have any questions. Next up, we have array functions, so prepare yourself. All right, you've wrapped up Chapter 8. You're cruising along. You finished the formula formatting section. Now it's time for your next homework assignment. Open up the Excel homework exercise file, head to the Formula Formatting tab, and take a look at the instructions. We've got 6 steps here that are going to allow you to transform this data range from A1 to G25 using tools like the Format Painter, conditional formatting rules, color scales, icon sets, and then some advanced formula-based formatting rules based on values in text. Good luck!